So we need to find 3 by 3 matrix A that has eigenvalues 0, 4, and -4, and given eigenvectors. Now matrix is similar to the diagonal matrix D if there exist matrices P and P inverse such that A equals P times D times P inverse. And diagonal matrix D consists of eigenvalues as the diagonal entries. And the matrix P is a matrix that has eigenvectors as its columns. So that means that D equals. So our eigenvalues are 0, 4, -4. So diagonal entries are 0, 4, -4, and the rest of the entries are zeros. 0, 0, 0, 0, 0. And matrix P consists of eigenvectors as columns. So the first eigenvector is 0, 1, -1, so it's the first column. The second one is 1, -1, 1, the second column. And the third one is 0, 1, 1, the third column. So that means that A equals to matrix P times matrix D and times matrix P inversed. P inversed. So before finding A, let's find P inversed. So P inversed equals, it's a 1 over determinant of P multiplied by adjoint of matrix P. So this equals, the adjoint of matrix P is 1 over P, and the adjoint of matrix P is -1 times 1 minus 1 times 1. Here we have -1 times 1 minus 1 times -1. And here we have 1 times 1 minus -1 times -1. 1. Then in the next row we have -1 times 1 minus 0 times 1. Next we have 0 times 1 minus 0 times -1. Next -0 times 1 minus 1 times -1. In the next row we have 1 times 1 minus 0 times -1. -0 times 1 minus 0 times 1, and 0 times -1 minus 1 times 1. And this whole thing is transposed. Well, I'll move this a little bit. So this whole thing is transposed. So let's do the calculations. We get that P inversed equals 1 over determinant of P times -1 minus 1 is -2, then 1 plus 1 is 2, and here we get -2, then 1 minus 1 is 0, then 1 minus 0, it's 1, and minus in the front, so -1. Here we have 0 minus 0, so it's 0, -0 plus 1, so it's -1, 1 minus 0, so it's 1, 0 minus 0, it's 0, and 0 minus 1, it's -1. Transposed. So this equals 1 over the determinant of P. Well, now let's write down the transpose of this matrix. It's -2, -2, 0, -1, 0, -1, 1, 0, -1. Well, now we need to find the determinant of matrix P. The determinant, since P is 3 by 3 matrix, we will do the expansion along the first row, and we get the determinant of matrix P equals, so here is matrix P. Wait, let me copy paste it. Matrix P. The determinant of matrix P equals the first element of the first row, so 0 times the determinant of negative 1, 1, 1, 1, minus 1 times 1, 1, negative 1, 1, and plus 0 times 1, negative 1, negative 1, 1. So this equals 0 minus, here we get 1 times 1 minus negative 1, so it's 2. And here we get 0. So the determinant is negative 2. That means that our inverse, P inverse, equals negative 1 over 2 times this matrix, the adjoint of P, which we got here. Negative 1 over 2 is a scalar, so we just multiply each entry by it, and we get 1, next 1 over 2, negative 1 over 2, 1, 0, 0, 0, 1 over 2, 1 over 2. Great. Now we can find A using our P times D times P inverse formula. So P is right here. This is matrix P times matrix D. So times matrix D and times P inversed. Well, first I multiply first two matrices, and here we get, so as you can see, the first column of our second matrix is 0, so the dot product of the first row and first column is 0. Then next entry is 0 times 0 plus 1 times 4 plus 0 times 0, so it's 4. Next entry is 0 times 0 plus 1 times 0 plus 0 times negative 4, so it's 0. Next entry is 1 times 0. So again, the first column of the second matrix is 0, so here we get 0. Then 1 times 0 minus 1 times 4 plus 1 times 0, it's negative 4. And here 1 times 0 minus 1 times 0 plus 1 times negative 4, so it's negative 4 again. Here 0 again. Then negative 1 times 0 plus 1 times 4 plus 1 times 0, so it's 4. And negative 1 times 0 plus 1 times 0 plus 1 times negative 4, so negative 4. And this is multiplied by P inversed. So this equals 0 times 1 plus 4 times 1 plus 0 times 0, so here we have 4. Then 0 times negative 2 plus, 0 times 1 over 2 plus 4 times 0 plus 0 times 1 over 2, so it's 0. Next, 0 times negative 1 over 2 plus 4 times 0 plus 0 times 1 over 2 is 0. Next, 0 times 1 minus 4 times 1 minus 4 times 0, so it's negative 4. Then we get 0 times 1 over 2 minus 4 times 0 and minus 4 times 1 over 2, so it's negative 2. Next we get 0 times negative 1 over 2 minus 4 times 0 minus 4 times 1 over 2, so it's negative 2 again. And the last row we get 0 times 1 plus 4 times 1 minus 4 times 0, so it's 4. 0 times 1 over 2 plus 4 times 0 minus 4 times 1 over 2, so negative 2. And 0 times negative 1 over 2, 4 times 0 minus 4 times 1 over 2, negative 2 again. So this is our matrix A. A equals this matrix.